Bacharov and Matthias Booz, and today Andrew and I are going to be giving an overview of what's been going on in Beaker, things that we've been working on for the past few months, and some of those things that we're going to be working on in the future. Timing on this is actually a little bit funny. We're doing a lot of heads down work on some new stuff that we're not quite ready to show yet, so we're going to be mostly covering stuff that we've talked about publicly in some capacity before, but it should still be a good overview of those things, and hopefully it won't be too short of a talk on kind of the stuff that we're just not ready to get into yet, but we're definitely excited for. So with that, these are out of the way. Let's dive in here. So in the middle of last spring, we released the Beaker 1.0 beta. Beaker has actually been in development for about 4 years, so that took us long enough. And the 1.0 beta was actually the result of a years-long heads-down period where we stopped all the Beaker releases and decided to really start a lot of things from scratch, from the user experience to integrating the new hypercore protocol. And so after a year of, really more like 14 months of doing that, we finally got the 1.0 beta out, and we've been really happy with a lot of the results that we've gotten. Feedback overall has been really positive, and we're learning a lot from that beta process. And so what I'm going to do is I'm going to talk a little bit about some of the UI work that we've been doing and the kind of philosophy that we have behind that. And then Andrew is going to talk about the situation with the application platform side of it, the kind of capabilities that people are building applications on, and talk about what's working there, what's not working there, how we're planning on moving forward as we keep on getting feedback about how these tools work. So let's talk about the UI side of things. This will be my part of the talk here. As we've been working on the UI, we've been thinking about how Beaker is not just a browser, but something actually much more active, because we don't just have the read-only web that we have here, but we have a writable web, which is able to do actual computing, able to run applications entirely on the user's device in a local-first fashion. And using this hypercore protocol, which is not just a way to connect to devices and get pages, but really sort of a database layer that is capable of running a variety of applications. And so you introduce a lot of new interesting challenges for a browser with a design like this, including things like data management and application management. And so in a lot of ways, we think about Beaker not just as a browser, but as a computing environment for information. So it's almost sort of more like an Emacs or an operating system. And in a lot of ways, the UI work that we've done has been designed to reflect that, and we continue to kind of focus on that idea as we move forward. So with the 1.0 beta, we included a bunch of built-in tools to reflect this. We had the built-in editor, which, not just viewing source in this situation, we're actually editing the source. Really big part of the thing, because we want people to be able to build websites and applications, so having a at least decently featured editor built in was a pretty core piece of this. We also included a files explorer for looking at and managing the files inside of your hyperdrives, so that you can do basic management, move files around, rename, delete, and all that sort of stuff. Also good for exploration. We also decided to integrate a terminal environment we call WebTerm. And this one was, to be honest, in part just for the fun of it. We figured, hey, we could do it. Why not give it a shot and see how it works? And it's been an interesting experiment. It's sort of a Bash-like. It's not Bash, it's totally built custom, but we take a lot of inspiration from Bash, and we're able to take advantage of some of the aspects of the environment to do unique things, like have nice autocomplete, and it's a couple of UI elements in there, like if you have a link or that's inside of the output, you can click it to navigate to that thing. And you can even drive the browser with the thing, which is fun, so you can actually CD around, use the CD command, and that'll actually cause you to browse. So there's a lot of kind of neat things we can do with WebTerm, and I don't even think we've really opened up all the possibilities there since we've been focusing on other areas. So it's one of those experiments I look forward to playing with more in the future. But of all these built-in tools, one of the really key things was getting an idea of UI composition involved, where these are not just monolithic applications that are living on their own, as we traditionally do on the web, but actually a series of relatively small focused tools, almost in a sort of a Unix philosophy, which can then interact with each other. And so we've been focusing a lot on this idea of a sort of a window manager, a tiling window manager within the browser, so that you can have multiple applications active at a time and have them interact with each other and provide different kind of views and tools for what you're browsing to. So whenever you open up your editor, you can have your editor and your web page that you're working on side by side. And as you write something and then click save, it'll cause the page to automatically reload. And then when you browse to a new page, that code will load up automatically inside of the editor. Same thing with the terminal and the Files Explorer. Having this level of integration is a really key part of what we're trying to work on here, because again, we think of it as an integrated computing environment. So one of the recent additions that we made was an API for leveraging this, and this is something that's still in development. I'm actually doing a little bit of work refining this right now in the current sprint. But we have a nice API where you can attach these panes to each other. So a pane can sort of say, or really a web page can say, I'm a pane, and I like to attach to other panes, so please allow me to attach to the last active one, and all this is going to be behind permissions, of course. But once it does that, it can do some interesting things. It can see what URL that current page is on, so that it can load relevant information, things like maybe annotations or comments or the actual source code itself, or do things like scraping. And that's why we also included things like the ability to execute JavaScript in the pane or inject CSS, and also to trigger navigations. So it's really about compositionality is a big part of what we've been working on in the UI layer. And we're going to be thinking a lot more in the near future about how we can leverage tools like this to make this environment something which is much more powerful. Again, a computing environment for information, not just for browsing, but for computing. One other UI element that we introduced that sort of relates to all this is this idea of minimizing tabs. And the only reason I bring this up is it sort of reflects how we think of this as a computing environment. You know, minimizing is something you do on a desktop, and we decided to bring that into the browser. And there's a lot of reasons that we felt like this was useful. There's the basic tab management, which everybody's always suffering under, and so it seemed like a nice ability to be able to just get tabs out of the way, put them in the background. But these actually don't go into any kind of a dormant mode. They stay active. And the reason that we did that is that we know that there are times where you're running, these applications, you're running them on your device. The browser is really running self-sufficient applications. There's not a service running somewhere for these things because they're peer-to-peer. And so there are times where you have a long-running application that you need to keep going. It's something like an index or a chat program, or eventually we're going to have a services stack, so maybe you're running a server. So this idea of being able to minimize tabs into this shelf space is designed to really focus on, again, the computing environment. The idea that you're opening up a web application that is running as almost like a process and can continue to run background. And for me on the UI stuff, like I said, there's lots of other things that I just can't quite talk about yet, but I figured it'd be nice to give an overview of what we've been doing and sort of set the stage for how we're thinking about this. So now Andrew's going to take over, and he's going to tell me when to go to the next slide. So Andrew, take it away.
Awesome, thanks. All right, so I'm Andrew. Handle is Andrew Roche. I work with Paul and Matthias on stuff in the general space of Hypercore Protocol and Beaker. And so today, Paul kind of set the stage by talking about how Beaker is a lot more than just a browser. It's more of this environment for computing with your information. And so a big part of that is building applications that can take advantage of that. So what I want to go into a bit is, what are the APIs that are in Beaker to make it easy to work with your personal information and then share it in a peer-to-peer way. And I mostly want to focus on the APIs that are relevant for the Hypercore protocol, like how the Beaker browser uses the Hypercore protocol internally. And so part of that, I'll kind of get into a little bit of how the sausage is made with how Beaker wraps some of the Hypercore protocol tools and then builds on that. But I kind of wanted to do it in a bit of a story-driven way. So I want to kind of walk you through a handful of the applications that we've seen built on Beaker so far, and kind of tell the story about how we've gotten to where we are now, and to the design decisions that we've made for kind of the next iterations of Beaker. So with this slide, you can see the wonderfully named Blobbity Blog, which is our main, or one of the main demo applications that was shipped with the Beaker 1.0 beta. And Blobbity Blog it's a pretty simple application that that basically all boils down to this one API right here, beaker.hyperdrive.query. And what this does internally is it really just does a bunch of file system reads, looking for markdown files in your microblog folder, and the microblog folders of a handful of people that you follow in Beaker. And so this application, just as a little tangent, it was really fun to see when we launched the 1.0 beta. Lots of people, the original version we shipped of Blobbity-Blog was pretty bare bones. It didn't do too much. But then we saw people in the community just make all these great forks using Beaker's fork and merge tooling that's built in, and extend it with things like inline replies. And eventually, these forks kind of propagated throughout the network. And yeah, you can see the posts that were there when I took the screenshot. But yeah, so anyway, yeah, sorry, I got derailed there. But yeah, so Blobbity-Blog it was very fun to see that kind of evolution happen with these new versions propagating around. But I wanted to kind of show this off as an example of kind of the more simple applications that are built on Beaker that really make good use of just the Hyperdrive API on its own. Hyperdrive is the main peer-to-peer storage API that we expose. And in this case, because all it's really doing is reading a bunch of files and then sorting them by time, this application is pretty well suited for the APIs. So kind of a general theme of what I want to talk about is kind of where there's a bit of a mismatch between the APIs we expose and the applications that people are trying to make, and kind of learning from that and figuring out what APIs might make sense to do next. But as far as the Hypercore protocol stack goes, there's another API that we introduced as part of the 1.0 beta. And Paul, if you could take it to the next slide. Cool. So we added this thing called peer sockets, which was one of the main requested features in Beaker. People, they had the storage APIs for writing files, but people really wanted to be able to make direct peer-to-peer connections to other peers that are viewing a site with you. And so we decided to take a stab at that with the 1.0 beta. And we initially shipped this with just basically a handful of demo applications. So we had a chat demo application and we had this video chat demo application, but we kind of saw the community kind of latch onto the idea and tinker around with it and make a whole bunch of cool things like this offline badge here, and even a game that you could go into and walk around and chat with people. But you can see in these screenshots that there isn't too much activity in these particular applications. And I think a big part of that is because our first attempt at these peer sockets, they're pretty unreliable. And the reality of that is that the peer sockets programming model, it has a bunch of kind of hidden constraints that make it really challenging to program against. So we expose this pub sub style system where you can join a topic and then watch for peers that are coming in on that topic. But because of the way swarming works in Hyperswarm and the Hypercore protocol, there's no guarantee that the peer that you expect to be swarming is going to actually make a connection to you. You're only going to connect to a subset of the people that might be swarming a particular discovery key. And so when you write an application where you have the expectation of say connecting to the owner of a drive, if you know that drive is online, that might not be true. And so we started to see this becoming more and more of a problem. And then this all kind of culminated, or at least for me, when Matthias, who kind of likes to push things to their limits, decided to build. Oh, that's a bummer. Oh, there it is. Okay, so there's a screenshot here. The user submitted drives peer service. So what this is a combination of a handful of things. It uses peer sockets, but it does so in a way where a user will connect to the service and then we'll send a request to the peers that you're connected to saying, hey, add my link to the aggregator. So the idea is that anybody could say, I want to add this link. And if the drive owner is online, they'll get that message and then index it. And this is where everything really kind of broke down. And we realized we needed to kind of come up with a more structured approach to managing direct peer-to-peer connections, because in that scenario, the service doesn't work unless you're able to establish a connection with the drive owner. And peer sockets, the model just didn't really translate for that. And this example also highlights another thing that I wanted to mention, which is indexing. So with Blobbity-Blog, the posts are basically just time ordered. So you don't need too much complicated indexing to just load them in and display them in a time ordered view. But with a link aggregator, you really kind of want a more powerful database where you can store metadata about links, and then things like upvotes, downvotes, and come up with creative sorts and rankings for these values. Excuse me, I'm just going to drink some water. So this was launched, and it worked for for a handful of cases, but it never really got to the reliability that we wanted. And so yeah, so we learned from that, and that kind of informed the next directions that I'm going to talk about in a second. So just to kind of summarize here a bit, we have this big, this kind of diversity of applications that are all shoehorned into a handful of these hypercore protocol APIs that are being exposed by Beaker. And they're all, for some of them, they're very well suited for that, but for others, you really want something more. And this general situation kind of hints at the need for some kind of set of more powerful APIs that directly surface some hypercore protocol features. And so, the question is really, what's the ideal here? These applications, they worked, they were possible, but how can we make them one click? How can we make this whole process less kludgy? So to start, I kind of want to, Paul, can you jump to the next slide? Cool. So to start, before I go there, I want to kind of talk a little bit just about the current architecture of Beaker and how that uses the hypercore protocol stack inside of it. And so here's a little cartoon overview of what that looks like. So you have your hyperdrive daemon, which is one of the main modules inside the hypercore protocol ecosystem for dealing with hyperdrives. And what that does is it's designed to give you this batteries included experience with working with hyperdrives and making them available to other people. So the idea is that this is a service that runs on your computer, and it gives you an RPC API for accessing your hyperdrives remotely. And internally, it uses a handful of the modules that you've probably already heard about from the other talks today, but it uses Core Store and the Core Store Swarm networking module, and it basically wraps this all up into a single, or well, two rather, APIs, this remote hyperdrive API and this PureSockets API. And then Beaker kind of works with those to power its APIs that it then exposes to web applications. But the idea is that all the networking, all the internal data structures, they're not exposed in this at all. They're all just kind of bundled into remote hyperdrive. And so there's very little flexibility there. But at the same time, Paul, can you jump slides? Cool. So that kind of hinted at some kind of redesign. So we started thinking, how can we make a lot of these internal features available to Beaker? That was how the conversation started initially. And we started talking about potentially extending the gRPC APIs inside of the hyperdrive daemon to handle other data structures as well. But then we realized that there was a better way to approach this, and that our RPC API was not at the right level. It wasn't at the correct level of the hypercore protocol stack. And we decided instead to go to a lower level and expose Core Store directly. And you've probably heard a little bit about Core Store, but just as an overview, a Core Store is really just a hypercore factory. It's a wrapper around a collection of hypercores, and you can call git on it and get a hypercore out. But it's just a nice way of managing collections of hypercores, like the kinds you would see in say, in a hyperdrive. And the networker is just a simple way of connecting a Core Store to the Hyperswarm DHT, so you can easily discover peers that are interested in hypercores that you have. And so we basically, the motto here is remote access for everything in the hypercore protocol stack. We want to kind of provide the easiest to use API for doing that. So it comes with, you can see this code example here on the right. We're now directly making the networking API accessible for the Core Store networker. And it's pretty simple to use. It basically has the same API as the new @CoreStore/networker module, which it exposes just a single configuration method for choosing if you want to announce hypercore on the network. And Paul, next slide. Oh, great. Okay, and then also that we replaced remote hyperdrive with just this Core Store API. And what's nice about this is that then you can see in the code example here, a remote hyperdrive is really just a normal hyperdrive. You just pass in a remote Core Store. And this all works with very few changes, which was pretty cool. And it means that all of the data structures that we've made and many of the data structures that the community have made are now just kind of immediately usable from within hyperspace. And so we've been really actively pushing on this, and we're very close to releasing it, and it should be there pretty soon. Next slide, Paul. Cool. So now the question is, how are we going to end up using this inside of Beaker? So ideally, we want to swap out the hyperdrive daemon and replace it with core store. And so how is that going to make the app development experience better for that set of applications that was previously kind of shoehorned into using those two APIs? So the main things are we're planning on adding hypercore APIs into Beaker, so extending what's possible inside of those web applications. And with those hypercore APIs, you can build arbitrarily complex indexing structures. So maybe you want to just use a hypertry to store your links. Well, you can do that. But maybe you're doing some wacky experiment where you're trying to build a B tree out of a set of hypercores, and that'll be possible inside of Beaker as well. So the idea, is to provide some set of stable kind of orthogonal low-level APIs that are all exposed inside of Beaker to kind of enable the broadest set of peer-to-peer applications that you can build. And yeah, as an example of another one that we want to add alongside of the hypercore API, Paul, can you, next slide? We want to add peer services. So I was kind of hinting with peer sockets that they aren't quite enough. And especially with the user submitted drives, we saw that we wanted to make these direct connections to the drive writer or the drive owner so that they can add links from other users that are connected. And so we thought about this a bit and decided that we wanted to come up with some kind of approach to making services where you can kind of model this with more structure and clarity. And we decided to kind of go with a client server design where you can create a key pair directly and then announce this on the network. And the writer would be basically the only one announcing this key pair. And so when you join a website, you're just going to make a short-lived connection where you do a lookup for this service, and then you connect to it. And on both sides, the interface that you have is really just a simple request response interface where you can say, hey, request, upload this link to your link aggregator, and then you'll get a response back. And then you can, when you terminate the connection, it'll close it. So you can garbage collect these connections more easily, and it should just be pretty nice to work with. Something important here is that we also want to make it possible to prove ownership of drives, because we think this pattern with the user submitted drives is going to be pretty popular, where you're running some service that users are going to connect to and say, hey, can you update the hyperdrive that you own or the hypercore that you own to include this piece of data from the request? So we want to be able to really quickly craft these proofs that you can then distribute, saying, hey, I own this hypercore, and then the remote peer can easily verify that they're connected to the person who actually owns that core. And if they're not, they can just stop doing what they're doing. So this is peer services. It's still in the design stages, so nothing here is finalized yet, but we are excited for what it can do. And I think that's it for my overview. But I just wanted to say thanks to the organizers and thanks for listening. So back to you, Paul.
Yeah, and I don't really have anything much more to add than that, except that I'm pretty excited for the peer services. That's going to be with the proofs system that he was showing at the end there. Let me go back to that slide real fast. You're really getting the ability to do authenticated connections, which I think is a really exciting feature to have in this system. But you're also just going to get a lot more reliability about the connections. So again, you're getting clarity. I'm either connecting to the person I'm trying to connect to, or you're not going to. And it's very binary in that regard, as opposed to the peer sockets, which really leaves you in a somewhat indeterminate state. So the peer sockets are almost like a UDP compared to the TCP of peer services. Hopefully that metaphor holds up pretty well. But and there's a lot of really interesting things we could do here off of this protocol, really focusing on what I like to call the communication suite, where people could start to be able to send, things like direct messages to specific people. I have some ideas for how we can get asynchronous messages going on the system, so kind of a mail queue, which would be really valuable. And once we have this sort of bidirectional communication, it helps a lot with kind of collaborative use cases, things like sending, what we call, quote unquote, pull requests to each other, because we have the forking and merging tool. So you'd be able to send those links to the person that owns the drive. Really important use case right there. Getting some of the stuff that's geared towards forming groups together, which involves everybody that's in the group has to create a drive to participate in the group. So having the ability for somebody that wants to join a group to be able to connect to the group owner and say, hey, here's my drive to participate in the group and get that set up. It will really hopefully help people get much more connected than before. You can even do things like friend requests, so to speak, because right now there's so much of it is geared toward the idea that you have to more or less subscribe to each other's hyperdrives to see their content. So like in Blog, for instance, you only see the posts of people that you currently are quote unquote following. So being able to send a request saying, hey, you want to follow me? That'd be a nice feature to introduce. There's been some cool work recently on an idea of sort of like web mentions for Beaker World, and that will get vastly improved by something like this, where you can send over ping saying, hey, just so you know, I liked your thing, or I replied to your thing. So if you want to pull down that URL and index it locally, you can do that. So this will really, I think, help close the loop on a lot of the person-to-person communication in the system, and also be really great for running basically services on the peer-to-peer network. And in a lot of ways, I'm keen to see, this stack should be replicatable on the on server environments as well. So I would really love to see that this idea that the peer services can be used not just to connect to other browsers, but to connect to services running on a VPS and have just kind of total orthogonality with that thing, where you're not really caring whether or not you're talking to something that's sitting in Google Cloud versus something that's sitting at home. But it's all just one stack for interacting with people. So that pretty much wraps up the talk, and I think we have time for Q&A. And Martin has kicked us off. Is there a way for other desktop applications to interact with the services, sockets, and course store? Andrew, you want to take that one?
Yeah, sure. So I imagine you're referring to these things all being inside of hyperspace, because in that scenario, then yes, you can use the hyperspace client and connect to it over just a Unix domain socket, and it should all just work through that.
Yeah, so the core pieces for all these new APIs should be exposed by hyperspace. Obviously, HyperCore already is, but I believe Pure Sockets will be one of the exported RPC interfaces to hyperspace. Is that right, Andrew?
Yeah.
Yeah, and Pure Sockets already are.
I think I misunderstood you. Pure services being exported as one of the main things on hyperspace. Is that what you said?
Yeah, isn't that the plan, or what's the plan, or how they'll?
Yeah. We currently expose through the networking API the ability to do stream level extensions. So that's going to be the main thing that we expose, and then Pure services are just going to be written on top of that in userland.
So Pure services will be similar to how like hyperdrives work on top of remote hypercores.
Yeah, exactly. The stream level extension API should give a lot of flexibility in building applications that like Cabal, for example, that wants to send related feeds, and similarly with Pure services, they'll all kind of work with that API.
Yeah, so that'll either be a module that can get reused, to take out a Beaker, or just code that's easy to copy and paste.
Yeah, that's true.
Martin's asking, would another app need to ship their own hyperspace? We haven't tackled yet, so really, Andrew, you've been the one working on the hyperspace port of Beaker, so I haven't looked into yet the question of how they'll coordinate whenever there's more than one daemon active. So what's the status on that?
Yeah, so one thing about hyperspace that should be good is that it has a very reduced API surface compared to the hyperdrive daemon. So we're imagining that the APIs will be extremely stable for a long period of time, because like Matthias said in the talk, the ones that we're exposing through hyperspace are pretty much frozen in terms of the APIs there. So hopefully compatibility, or at least API compatibility, will be less of an issue long term, but there's still going to be mismatches in the future, but hopefully it'll be in the far future. So as of now, Beaker will basically check to see if a hyperspace instance is already running, and then make sure that the protocol version or the schema version is the same, and if it's not, it'll fail to connect. And tricky issue in general.
So it sounds like we're going to take the same approach as we had before, which is yes, that every application would ship with their own hyperspace daemon. Oh, am I still online? I just had a little thing saying I was disconnected. So every application would ship with their own hyperspace daemon if they, unless they have for some reason think that the daemon is going to be available, and so then they'll use whichever daemon is already running. But if one isn't, they should spawn their own, and that sort of helps us. That design simplifies the process of updating the daemons, because then it's just a matter of each application shipping a new version with the updated daemon if the daemon ever has an update that needs to get shipped.
Right. Yeah, and then the clients would just refuse if the schemas are incompatible.
Right. Okay, any ideas for improving IP address privacy? I hit on this before, Cinnamon, and so I'm just going to cover this really quickly. We basically, it's something that we're openly talking about and trying to solve. And it's ultimately going to come down to either a distributed proxy or a non-distributed proxy. So Tor I2P or traditional proxy service. And that decision really comes down to what kind of performance and effectiveness we can get out of the distributed proxies. We need to spend some time researching those and seeing if we think one of those are winners, doesn't slow down the network too much. Obviously, that would be preferable to have a distributed proxy, but there's trade-offs involved. So at the minimum, I expect that we're going to have some kind of proxying solution, whether it's distributed or not. We don't know yet.
Cool. And
all right, what about
Oh yeah, I was just gonna say, I'll read this one. So what about access control? What if app A attempts to interact with hypercore it should not have access to? So I'll maybe answer this at the hyperspace level. In hyperspace, this is all operating on one shared core store, so there's really no notion of permissions. Anybody that connects to the daemon has the same kind of user-wide permissions for accessing all of those hypercores. But then the client, in this case Beaker, will then have to somehow gate that with its permission model. Yeah. Okay, so that was a question about hyperspace. So then, yeah, that's the answer for that.
Yeah, Beaker has its own permissions model, of course, and that'll continue to evolve. One of the things that we're keen to do is introduce a mechanism where currently anytime you create a hyperdrive, it has to be added to the library, which kind of makes it a little bit difficult to create new hyperdrives, and sometimes applications need to make hyperdrives or hypercores that are just scoped to the application. So we're going to look into creating a kind of a per origin library, similar to like how local storage or indexed DB operates, so that you can create these various hypercore data structures without having to task the user with adding them to their library and things like that.
Okay, so different users need to run their own hyperspace. As of now, yeah, that'd be the case. We don't have any notion of permissions beyond the standard writable permission in hypercore, which is going to be the same for anybody who connects on that socket. So if we're going to add any kind of user-specific permissioning, it would have to be in a layer on top of that, or we would have to extend the API to say, to kind of define permissions there somehow.
Okay, Jeremy is asking how panes interact with crypto, shared memory, and etc. Could you expand on that question a little bit? The panes are really just normal, web views that are being put side by side. So it's really just kind of a UI trick is all there is to that. So yeah, maybe expand on that question. I'm also going to take the next one since this, I'm the one that's worked on this. What's the status of Beaker Node? Would that work as Beaker Lite? So wouldn't work as Beaker Lite. Beaker Lite is something we were talking about earlier, a simple desktop application for managing all your hyperdrives. Now Beaker Node, the idea is that it's a sort of a node program that reproduces the web environment for basically running scripts in a VMS. And the idea is to create an orthogonal execution environment so that a website or a web application or script that was designed for the Beaker web could get run in a cloud environment. And part of the dream there is that you would be able to have applications which could ship up into the cloud. So you could start it on your own device, move it up to the cloud, and not have any break in its execution. That's kind of the long-term dream of that. And I've done some initial work on reproducing that environment, and actually Ranger has done some pretty cool work on this too with WebRun, and had some good early success getting some of the basics done, but put it on pause while we focus a little bit more on Beaker browser. So the summer roadmap idea of getting Beaker Node done during the summer, probably not going to come to pass, but it definitely is still on our radar. And it's I like it a lot as a concept because you'd be able to write services so simply in that system that it would really, I think, open up development in some fun ways. So if anybody's actually interested in taking up that project and contributing to it, it's in the I believe if you look at our GitHub or the Beaker browser, I think Beaker Node is public, so you can see where we're at and flex with it a little bit if you're interested.
Okay, I'll take the next one. So what about a data wallet app that can have a special relation with the hyperspace daemon to potentially confirm or reject data access requests to other apps? I think that could be done by the socket that the hyperspace client connects to is configurable. So you can tell it where you want it to connect to, and you could potentially proxy those RPC requests through some other kind of service to do that kind of gating. Might have to think about that one a bit more though.
Jeremy expanded on the question. So pure services involve proof if you squint. Could maybe if panes lack isolation, an attack can be crafted. Okay, so like the panes are actually still isolated wholly. They're running in completely different contexts. They should be running in their own processes based on my understanding of how Chromium operates. And the only way that panes are breaking that isolation is through the Beaker.panes API, which allows them to communicate with each other to varying degrees. The most egregious of those breaks being the ability to execute JavaScript or inject CSS into the target pane. And that is gated behind a permission prompt, which is very visible, so that can't happen. Just like, surprise, a application just ran. No, they're not sharing memory. They aren't, everything's permission gated, so that, it's a little bit of a risk, certainly, and it kind of gets into the web extension zone with how that's operating, but it's not screwing with the fundamentals here. We try to be pretty conscious of how we're managing the security of this thing. Can also be controlled through content security policy. That's correct. I suppose if you were to set up set your application, you can actually set in the index.json, so the manifest of a hyperdrive, you can actually specify a content security policy. So if you wanted to disable script injection, I don't know if the API we use would override that or not. I'd have to check into that. It may be possible. It may be the case that the CSP would get ignored in that scenario. So let's test. Yeah, hit me up with an exploit. Got a couple of people typing here. While we're waiting for more questions, Andrew, you want to talk about how we're bringing back SOAP and XML into everything?
Oh yeah, of course. That's coming up right after the hyperspace port.
Can't wait.
Yeah, but I do want to say just thanks to the people whose examples I used in the talk. It's been really fun to play around with all the great little apps that are being made in Beaker. So I used something from Metanomial and Todd Robbins and Matthew Ald. And I featured Johan as well in the Blobity, so it's been really fun and a fun community to be in.
Yeah, it's been really fun seeing everybody work with this and find what works and what doesn't. There's definitely been some things that have been more successful than others, no question. But the feedback we've been getting has been really useful. And in fact, Johan, thank you very much for the rapid feedback you gave on the Panes API updates recently, because one of the releases really broke a couple of flows, and we had to get a quick update out on that. Johan did ask about Sodium, and I don't know if we're planning on exposing any more of the Sodium API. We might at some point, because there's a lot of value in doing that. We just have to figure out what the plan is on that front. Andrew, you want to take this one?
Yeah. So say I want to create a standalone hyperspace application outside of Beaker. Would I be able to expose this to Beaker in some way? So for a lot of this depends on how the hyperspace applications are translated to make sense in a Beaker context. So some of, so for example, the hyperdrive APIs, a handful of them aren't directly exposed one-to-one or weren't in the past. So in this scenario, for example, with peer services, that isn't actually going to be a direct hyperspace API. But as with peer sockets, you can import the node module and use it outside of Beaker as well with a hyperspace client, and the APIs in that scenario is the same. So I think a lot of these APIs are not going to be finalized yet, and maybe Paul has a little bit to add on that one.
Yeah, I would just say, Ro mentions that they're having a hard time wrapping their head around these terms. There's certainly a lot to keep track of on that front. Hopefully we'll be giving more clarity to that. But generally speaking, I think the way to think about hyperspace, the hyperspace daemon, is it's kind of like a MySQL or a Postgre, service that's running, and you can have multiple different applications interacting with it to access the data and the kind of the tools that it has. And so that's how this stuff gets shared. It's a service that's running in the background that multiple applications can use to interact, and as a result, you're able to get shared access to data. So any kind of data that's being put in there would be accessible by any application that connects to it. And then the other really big motivation for having the hyperspace daemon is that the networking stack really needs to be ideally only one of them running. You don't want to have multiple hyperswarm connections going on. You really just want to have just one, and so that's a big part of why that was done.
Right,
yeah,
so
because
next
also
one here. Yeah, I'll ask this one. So any considerations of exposing hyperspace to the conventional web, for example, via a loopback address? I think there are a couple of different ways to approach this. Where the hyperdrive daemon used gRPC, we're now using this new RPC system called HRPC, which is transport agnostic. So it should be pretty straightforward to expose that over a WebSocket, which could be a nice way to approach that. There's some of the work by Mauve, who is trying to come up with a good kind of HTTP language for working with some of the hyperdata structures. Might also solve this problem pretty well too. So I think either of those or both. I
think you would ultimately need something a little bit, that's designed to do that. So you might actually need an application running between hyperspace and the web, because you're gonna you're gonna need the thing to be pretty intelligent. It's gonna need to handle a lot of stuff that Beaker does. Exactly right. So handling things like permissioning, giving higher level APIs, because you don't want to just expose the hypercore interface, doing things like data management and stuff like that. So if you're thinking in terms of like an extension, the extension would probably need to be running some aspect of this. But even with an extension, you would still need a companion program to expose the RPC interface in a way that the browser extension can access. Unless we talk about maybe getting something like that into hyperspace, but there's concerns about exposing that on a loopback interface. You maybe just have to password protect it or something like that. So yeah, I mean, it's possible. I have mixed feelings about it, but who knows? Maybe at some point we can look into that. And HRPC is new. That's a custom new RPC interface.